what are we doing today? So we're actually doing Pythagorean Theorem. What can we now do is what Luke just told us. He said we now can use Pythagorean Theorem, PT, and its converse. Converse means you are not always just solving for C. You're solving for the A's and the B's and so on and so forth. To solve problems is what we're doing here. So we identified what a leg was, what a hypotenuse was, and exactly what the Pythagorean Theorem was. I know you already have this. Most of you already have this memorized. Okay, but that is something you're going to use over and over and over and over and over again in math. Not just in 6th grade, but for probably ever, as long as you continue in math classes and in life. Here's the diagram of the Pythagorean Theorem that's going by us right now. We identified the legs and the hypotenuse. Somebody explain to me the ABC and where the ABCs go, and if it matters, where they go. Jack.
A and B are the legs, and C is the hypotenuse.
Okay, is C ever not the hypotenuse?
No.
And A and B, can they be switched, Jack?
Yes.
Yeah, so the A and B can be switched. They don't necessarily have to be in the spot that you see in the diagram here. Algebraically speaking, what I'm most concerned about is, can you solve for a leg? I know you can solve for a hypotenuse pretty easily because you're not solving for a variable that is embedded in a problem. So the example on number 3 here, a squared plus 4 squared equals 12 squared. And then the blue represents the points if I were grading this on a test. The thing that I think most of us didn't realize is when we got down to this part right here and we had a squared equals 128, you have to take the square root of 128 and the square root of a squared so that a is by itself. And then this part you guys already had, 11 and 31 hundredths. Was that the key part, I think? Yeah. Make sure that you do not you do not leave a squared as a squared or b squared as b squared, because that is not getting the variable alone. The variable is still with itself, actually, in a square form. We did do an example on grid paper that is going to be important because you're going to see these again. So essentially, if you look at the blue here on number 6, you were given this, and you needed to take that to get this. So you needed to graph the points or plot the points, figure out what was being asked of you, do the Pythagorean theorem to solve, and then we are answering in units because we didn't give you a unit measurement, which a lot of you missed that. So don't forget about your labels. And then lastly, we did a real-world example with Anton and Brianna going their separate ways over winter break here. Here is the problem, and then my beautiful drawing follows. But essentially, we were trying to figure out how far Brianna and Anton will be over break, with Anton going to Reykjavik, cool trip, and Brianna going to Iowa, not so cool trip. And the distance between the two, these are actual distances according to the Google. I drew a picture, a very ugly picture, and in the picture, I was able to draw a right triangle so that we could find how far away these two would be as the crow flies, which means the closest distance. So from Iowa to Reykjavik, with the data that we received. Where would you ever use this? Brianna told us you would use it in architecture, and then the shortest distance between 2 points would be another way, as the word problem explained. Girls, I'm up here. Any questions? Any comments? Anything we need to add?